Mm. Hello.
Hello.
So, Carlos, apparently I was the first one to join, and it made me the presenter.
Oh, cool.
So, yeah, I guess that's a good thing. That way anybody can start the call, I guess.
Well, I don't know how Sean set up this one specifically, but for the chapters, I use the WebEx Schedule Pro, I think it's called Pro Web Meeting. And it didn't let me until I selected a person to be co-host. Only then that person can be the host.
So, I'm sorry to do this, but I'm going to make you the host, Carlos. I have half an hour. I just got dragged into this other thing for a customer. I'll be back. So, I don't know if you want to go through the ArgoCD setup we did for KP for the starting point, and then I'll come back. We can go into detail on the plugin after. That work?
Yeah, we can do that. I can present the high level, and then we can go to the details.
Okay. All right. I'll be right back.
Yep, no problem. So I'll show where the use case. So I have a bunch of stuff open. Sorry about that. Also preparing for a demo today on IBM Tech TV this afternoon on Istio and Jagger. So we are working with KP and other customers, also RBC and other financial things, customers. So one aspect of this, and let me get to the example. So is managing the secrets. So that's something that always comes up when we're talking about Tecton and CI/CD. Is super cool that you can put the Helm chart, which has the deployment, the ingress, the service, config maps, and everything. But then people ask like, we need secrets. We cannot put that in Git. And you're telling me that Argo is the one that is going to deploy that Helm chart into the task, staging, and production. One way is to go ahead and create the secrets manually, which is going to be a pain because it's okay for 3 apps, but you go to 300 apps, it becomes a problem. And one way we can do is not use GitOps, but use, I think we're going to use GitOps. At the end of the day, in the GitOps, but what we're going to store in Git is not the secret itself, it's the location of the secret. So for that, let me get the cluster. So this is a cluster we're using for a customer. We install the toolkit. The bread and butter of what we do with the toolkit is also use the toolkit to deploy the OpenShift cluster. So 20 minutes for the cluster, 20 minutes for the toolkit. And then we can get to doing that. This specific use case scenario or this example app is a Cloud Foundry app that got migrated. We're working with this client to show them what are the things that you have to do to a Cloud Foundry app to make it a Kubernetes application, and then on top of that, what are the things that you need to add to make it a good CI/CD pipeline. So if we go to the namespace dev as a developer, this is the app. Actually, it's in dev. So this is the application. I think it just says hello world. So it's a boilerplate application. So this is going to be a template. The same thing, we have patterns in the toolkit when you open the toolkit. Right, we have the pattern. This will be their pattern, and then the trigger. So if we go to the pipeline, and also let me show the repository, the Git repository, what is in there. So we click here, we're using GitLab. And what we did to this Cloud Foundry app was basically add the Helm folder. It doesn't have the secrets or anything like that. It just have the typical deployment and the ingress route and the service and such. So the pipeline runs and it's at the normal CI/CD, and there's some secrets in here to get it running. And these ones we did manually because it's for dev. So maybe this is using something. So the thing with this is, I don't know why, but there's certain things that I would like to see in the developer preview. I don't know if people have feedback. But I need to go to workloads and go to secrets, and I need to find my KP config secret. So they're using Spring Cloud config implementation. So this app, they have a one for Spring and one for Node.js, and for Node.js, they're using the kind of same service, Spring config with a shim, and then this is the secret. So this is the information that it will need to, the app will need to go to this endpoint to get their Spring Cloud configuration, and they have a password and they have a token. When this application runs in the pipeline, is let me see the pipeline run, the last one here. It will do everything and then do the GitOps. So the GitOps will go to the GitOps repo that has the information. So in this case is where is the, I can grab the URL here if I can find it. Git, yeah, this is the Git repository. So now it's connected to Argo through this Git repo. So in this Git repo, you can see there's a test branch and there's a master branch. In the master branch, we have some of the helper scripts. So this helper script, and we have some templates. So if you are going to use the secrets plugin, then the secrets plugin, this is a template, all the things that you can put in that secret plugin. So this is what you're going to store in Git. So you're going to create, this is a custom resource for a custom resource definition. So as you can see, Sean created an API scope, API version. We created an operator, so that's what Sean is going to show. The kind is secret template, and then it has certain annotations. So it's going to use key protect. So this is an idea of it can be extended in the future to do something else. So the idea is that we're going to store the actual secrets in IBM Cloud using key protect. What is the instance ID, and then what is the region? I'm going to show that when we show the real value. And then this is just, so this is a template for all the apps. So you will put this in that location. I believe you can also put the namespaces that you want this to go into. I think it's under annotations, but it's not showing here. Maybe it's in the other one. But this is, so in the template, it might be that you have information that is not secret. So sometimes we just put information there to have them together. Instead of a config map having half of the information and the secret have the information, then in the secret you have maybe a few data keys that are not sensitive, and then the other ones that are actually sensitive. So this is shown data this way to have the opportunity to behave for like the real secret kind, but it's plain text. So this is not, so this is, it takes a URL, it can take a base64 value if it's something that it cannot be put in strings, right? You can base64 it, or if it's a file, for example, a whole file in there, and then if it's a key ID. So this is the one that I think we're going to talk about. So this is saying go to key protect on this instance, on this region, and then find in that key protect this key and grab the value, and then create me a secret with that information. So that's the information that you will put. If we go to
okay. So I'm sorry, I'm a little confused there first. So initially I was going to ask, there's a username and a password, but that password isn't actually the password. That's just kind of a key for the password from that.
Yeah. These names will be the keys. This is something we have to go back with Sean. It's okay, right? We got it working, but I that's good feedback, Sean, Larry, because I had the assumptions like, see, if this is going to look like a secret, maybe this should be key, right? And then this could be data, and then this could be data string. Like for me, I'm a YAML, like Kubernetes YAML expert every 24 hours, right? 7 days a week. So I know by nature how a secret.yaml looks like. So if this is going to create one, if I put them side by side, I want to have a correlation. So that's feedback I want to give Sean. So I could see that we can change this to be something like this could be the keys. So when you go to the secret, those are the keys. And then this is in a secret, you know, that we have two ways of putting the information, data and data string. Data is the base64, data string is just plain text, because what I talk about, like, it's not important to be sensitive. So this is going to be data string. This could be data, and then this is, instead of being key ID, it could be like external key reference. So this will go to the external on the key manager, or it could be key manager key or something like that, to refer that this is going to be from the outside world, not coming from the same file. So iteration 0, right? That's where feedback comes into. So how does it look like this current version? And Sean is not here, so I need to explain that again to him. Again, so we created a file, a folder here, Node.js client secrets. So Node.js client has the Helm chart that we're going to deploy. Somebody's pinging me on Slack. Give me 1 second. So this is the app. This is where Argo is going to deploy to the Node.js. To the namespace test, for example. So and this is the values.yaml. So this is, we have the information about the overrides. This will have your typical toolkit. Where is the chart located? So it's located in Artifactory. What version it is? So this is the typical GitHubs. Then the other folder is the one for Node.js client secrets, and look at this YAML. So this YAML, and then Sean put here just for testing purposes. So this is not related to the app. Is this one? So I need a secret with the key called kpconfig, and that the deployment is configured that this will be an environment variable inside the application. The key ID is the key ID in key protect, and then this is the information on how to go to key protect and get that information. So Argo has a IBM Cloud AIM API key to be able to connect to IBM Cloud, to this instance on this region, and to this key protect to get that information and back. So let me show the other steps. So the first step is put this information in Git, not my sensitive information, just a pointer. So this could be like, this could be extended, right? The operator or CID can be enhanced to support Vault, or it could be supporting another place that holds secrets. But this is a use case where some customers don't actually never want to see the secrets stored in etcd database. Those are the customers that would do it through the init container that goes and connects and get it, or sidecar. This is a customer that is okay to have them in etcd, and maybe they can use HSM, the other feature in IBM Cloud that is hardware based and bring your own key. And they're okay to save that information easily, but it's like a pain to have to do that manually. So we're using GitHubs for the automation. So if we go to here, let me go to the resources and scope it just to our project. So I think we have a resource group. So this is kind of the best practice we always do. So we have our services for this MVP that we're doing, that's proof point results that we're doing with this customer. And then see, we have a key protect. I think it's this one, key protect. And if I open that one, then what I need to do is go into key protect. And this is where I rotate the keys. So if I have to go in here 30 days, I can use an API to do it, or I can do it manually. So I created one with, I think there were two because we were testing things. I think it's this one. So this is the ID. Well, let's double check which one it is. So this one says CDE9, this 86. This is the instance ID, and then CDE90 is the key ID. So it's this one. I'm going to delete this one. I think this one maybe was, I think I was going to use this one maybe for dev or for production. So, so if I want the, I can go ahead and view the CRN. I can copy this, but this is a standard key. Once it goes in, I think through the UI, I don't think it gives you ability to get the values. You have to use the CLI. I think if you do copy, I don't think you, what do you get back? I think it's just ID. Yeah, that's true. So that's correct. So this is, I went in here and basically did add key, and I can add a key, make it standard key, and then import my own key, standard key, and I can give it a name, foobar, right? Or I can say another environment. So we have a KP, Node.js, client, config, and we can say that this is prod2, right? And then what I put here is the JSON information that I show, like the actual, the string values. And in this case, this app is just like a JSON object and a base64, and we put it here. So that was the step that we did, and that created this entry. So I have the information stored in IBM Cloud Key Protect. I have the pointer in Git. So now how do I use ArgoCD to, anytime that I change this Git, it creates the it creates the secret. So that will be with Argo. I'll pause if there's any questions. If not, I'll continue.
Yes. Well, I guess maybe you're going to go there. But one other question, and I don't know if this is the best time to ask it. What if that key value changes? So
where in Git?
Or the secret, I should say. What if the secret changes in Key Protect? How would you refresh it in the container?
Yeah, so in Key Protect, these keys are immutable. They cannot change.
Well, so the values can change, can't they?
No, this is immutable. Like whatever you store, the materials that you store here are immutable.
Is there a version type thing so you can update it with a new version?
No, you just create a new key. Just add a new key, right? Just add a new key and then come into Git, right? And then change this Git ID for the new key. Like we changed the password, right? And change it here and put the new values. And then this would trigger Argo to go ahead and refresh the keys, the secrets in the Kubernetes cluster.
And then redeploy.
It could be redeployed, reorchestrated with Argo. But again, you have to be careful when you update config maps and secrets in Kubernetes, right? You don't want to just go ahead and automatically kick a deployment, right? You update the secret, and it depends on the app. If the app is, it's mounting a volume, it's checking again and again to see if those things changes, and the app can reboot itself inside, right? Or just take the new values. Or the other model is you update the secret and the config map, and then you do a rollout, right? You do like
upgrade, yeah.
Yeah, upgrade the apps, do a bump or something, and then when the next boot, it will pick up the new value. So that's separation of concerns, right? Normal. It doesn't matter if I did it with Argo or I did it manually, right? At that point, it is a deployment concern, how you want to manage that green-blue deployment, or you want to shut down the app and boot it up. Or like I said, if you have an app that you want to be aware, sometimes you don't want to make it aware. I was going to say smart, but sometimes you want to make it aware or not aware of using volumes, and then that way you can like check every 5 minutes to see if the files in the volume change or just load them from file. So that's why you have to be careful with Kubernetes. So it's a good question, because yeah, good question. So you cannot go here, right, and edit and change it, and it like magically Argo will know that you change it here. I think that's what you were going for, right?
Right. Yep. Exactly.
Yeah. So yeah. So there's not that magic in there. So you can either delete the key or not delete the key. And also ArgoCD, we're using it as a GitOps engine. So right now it's only watching Git. It's not watching other things. You cannot. It's not watching IBM Cloud every 5 minutes, right? You're just watching Git. So let's move to Argo. So we go to ArgoCD. Then what you need to do is, and maybe there's something that when Sean joins, explain to us why do we need to have a plugin. That's where I'm a little bit confused. Because my impression was if I have a YAML with a CRD, right, that exists, like secret template of this API version exists, right, we just want to tell Argo, go ahead and do kubectl apply this. And I think, yeah, so I think I know what it is. John will explain it. So you can do kubectl apply this, but I think Argo needs a plugin to be able to detect if you change something in the cluster, like somebody might mess up the secret template object in the cluster, then you want to make it sure, you want to revert back to make sure like the source of truth is Git. So I think that's where you would need a plugin to convert this into a secret. Or I think Sean is taking this and converting it to a secret. So I don't know that the code went to two transitions. He started as an ArgoCD plugin, and then he switched it to an operator. So let me see if this thing would allow me to log in. Taking a while. So I believe that the first iteration was just like this was not even a real like a CRD in the cluster. So you actually needed this could be like a text file. So you can create an ArgoCD saying, I'm going to take this text file and do some manipulation, read the file, and then create config maps and create secrets, create valid objects into it. But I think then Sean went ahead and did the extra step. Was like, well, let's make an operator with a CRD. So if I kubectl apply this, it's still a valid thing. But you need to install the operator. I don't know why I cannot log in. So let me check. Let me use admin. This happened the other day. I don't know why. Somebody else has issues with this. So let's go to the tools and get the password. Or I can do IGC credentials. Where's my password? Argo access. Yeah. And this is admin. Copy this. I don't know. I think it's AIM or something. Timing out. Okay. So I mean, and then what we did was created a new app, right? No more creation, and I'm going to point to this folder on this branch. So the test branch goes the namespace branch. Watch this folder, and then install. Refer here to the plugin. There's a plugin here, and you specify key protect secret. So this is the plugin that Sean created. So that I created that. So that one is this one. So basically, this is watching a secret or generating a secret. So it's generating the secret. So this secret, I bet it's going to be base 64 everything. So Somebody's calling me from. So as you can see, here's the kind secret, not that other one that we have in Git. So this is the secret that is configuring. So I'm thinking that actually Sean is watching secrets and creating this secret. So that's another question we can ask him. Like, this is not actually a CRD. So that's why you will have a plugin. So where's the options? I think I said here, if I do, how do I edit? App details, I think it is. I can do edit. See, we created the project KP config, Node.js, in which namespace are going to deploy this, or what is the Git URL, what is the folder, KP secrets, and then at the bottom it was the plugin, so it doesn't show it here, but when I created it, it created there. So for example, I can just create a test repo here for the demo, so I can show, like, I don't know, call it office hours demo, create it, and then I said, like, I didn't create that many secrets. Oh my god! So these are the Tecton ones, the regular ones, and then the Kubernetes, like, out of the box. None of these secrets are mine, right? So none of them have KP config in it. There's no KP config in here. But now if I create a new one, if I go back to applications and I create a new one, I can call this one office hours secrets. The project is KP config. Let's say that is automatic. Repository URL is the GitHub repo. So this is autocomplete because we configure Argo with the project. So that's gonna also a best practice. You don't have to type everything. The revision is, this is located in the task branch, right? And then we have a folder. What was the folder? That thing says KP. I don't know why it doesn't autocomplete. I wish it can autocomplete.
Yeah, with the plugin. I don't know. Sorry, I'm back.
All right, I had a bunch of questions for
Okay.
you. So I think this is the folder. I don't know why it doesn't autocomplete. Maybe that's the one. But in other cases, like when you're using Helm or Customize, it autocompletes.
Well, one thing, your branch has an S on the end, but it still wouldn't work. I don't know why.
Oh, that's a
Doesn't
typo.
identify it. But still, it.
Oh, there it is. No.
So is that it? No, the secret's folder.
No, I think why? Oh, I think I have a guess. So Argo is looking for valid Kubernetes stuff, right?
Probably. It's got to be under that directory path, right?
Like a deployment, route, services, maybe.
Yeah, but it still supports. Maybe that's it. Yeah, it doesn't recognize that CRD.
The UI, maybe the UI, right? It's
right.
like.
Yeah.
So put that here. Destination is going to be the in cluster one. Okay, which namespace? So what did I call this thing? Office hours demo. You're seeing a little bit of my Dory symptoms. I have short-term memory. So John, and then we switch this from directory to plugin. That's the idea, right?
So by default, so directory it'll just take whatever's in there and push it out. But in this case, since the CRD does not exist in the cluster, we're going to use a plugin to translate for us. So if we had an operator running that understood that CRD, we would just use directory.
Okay, so that's I think what I was explaining to who's on the call? Emma, Larry. Oh, there's other people joining. Hello. So I was explaining that if we had an operator, right, Argo just need to like kubectl to apply this and watch this thing, making sure that it's there. But you told me that we wrote an operator, and that is why we.
It's not been deployed. Yeah, it's not been deployed. So I started with the plugin. Partly, I wanted to understand what it took to write a plugin.
Okay.
But since the plugin was written in Go and the descriptor was written as a CRD, it was an obvious next step to just wrap that as an operator. So there's still some work being done to finalize that operator. And part of the reason to do the operator was to build out a CI/CD pipeline to create, to build an operator, to build a custom OLM catalog, and deploy all that. So that's why it started as a plugin to exercise it. If you didn't, I guess, if you're in an environment where you didn't want to install that operator, you'd rather just pick this route. We
are environments that we love operators. Everything is an operator. So I think I explained that the two options here was you can either have an operator that, and Argo is very dumb, it's just kubectl apply this, and then it watches two ways. Like if somebody changes some value from here, misspells something here, goes to the cluster and change it, then Argo will say like, this doesn't match the Git, let me make it, let's reconcile and let me get green, right? The other options I just said was, this is actually doesn't exist. I think you joined at that point. This is not a real thing in the cluster in Kubernetes because it's not an operator. But we want to translate. It could be a text file, right? It could be .txt or .ini, or it could be like a binary thing or a seal secret. Actually, yeah, it could be a seal secret. Like those seal secrets that people put in Git. Like this thing is encrypted, and then you have the key pair to decrypt it, right? You have the private key. So somebody with the public key encrypts the information, the seal secrets. So this is kind of what you're doing with the plugin, right? So we're going to select the plugin. I'll have the next question next. So the plugin, it looks like the plugin was registered or installed in this Argo. So this is why it shows up in here, not like I can put like foobar here. It needs to be like something that is going to get hooked.
You have to configure it in the Argo.
That's it?
Setup. That's it.
Okay, so I'm going to create it, and then I'll ask the next question is, so this will say this. I think this is the error we had last time, right?
Yeah. So the project. So you've created a project, but the project is restricting. So in ArgoCD, there's this notion of a project which is a collection of applications. And the project can be used as an RBAC mechanism to say, so you might have an administrator that sets up the project and then gives people access to that project. So the administrator can say, look, I will only allow this team to deploy, this project can only work in these namespaces, can only use this Git repository, can only create these types of resources, right? So it's a control point for the administrator. So by default, so you have destinations in there, but the new one, office hours, is not in that destination list. Right. So you can either do star, right, and say, hey, I don't care, deploy it anywhere, or you have to add explicitly this cluster, this name. And I don't know if you mentioned, Argo can deploy into remote clusters, right? So that's by default in cluster.
Yeah, we have one cluster configured, but you can have multi-clusters configured. Right. So that I think the beginning of the talk I explained like why we're doing this, because it's easy to do it with three environments, staging, pre-prod, and prod, but it's a nightmare when you have to do 300 of these secrets manually. So I'll put that here, right, and then update it saying, and this is also shows you kind of like governance type of thing, right? So it's also useful to learn that when we are learning, we put everything blank open, and then we go to an engagement and we have to lock things down, or we do it with blank open, we leave and the thing is open. Like we need to do, or people will start asking questions, how do I lock it down? How do I lock it down? So I should be able to go back, right, and then just add it here, and then create.
Yeah, if you create here now, it should let you do it.
Yeah, so now it's reading the information from Git. It's going to go to key protect, get that information. So Larry was asking around that if somebody changes these values, but you said we found out, or we already know that these are immutable. So you'll be creating a new one. You'll create a new one when every 30 days, right? If your rule or 90 days, you will create a new key and rotate them, whatever is your practice. But then this doesn't trigger Argo. You have to go to the Git repo, right, and change the ID of that new key to like the new key every 30 days. These things should change. And also in Git, you should see the audit log, right? Somebody like is rotating keys. Who did it, right? Was an automation bot or it was a person that changed this? And then we go to here, and then now since office hours, look at that. Now a new secret show up, and it should have my information. The other values is just for testing purposes. We're testing, and then that's the information in my app. So now I can deploy the app through GitOps, right? I can go and say configure Argo, configure Git, that this is a new environment, office hours demo. It's going to be a pre-prod environment, and then the app will get deployed through Argo in there. And I don't have to mess around with a lot of manual configuration or one-way configuration. So,
and if you, in the secret, there's a couple of annotations that got written.
Let me see. Why don't they display them? I would like there's so much white space here, right? Like use it.
So the plugin is writing. Okay, this is the instance ID, and then for
where
each
it came
key,
from.
That's where the instance it came from, and then the key that was used, and then the region, and right. So it you can kind of trace back how those got there.
Yeah, it might be good to add the resource group if we have it, right?
Yeah.
Or it's freeform, right? This thing takes freeform.
Mm-hmm.
The notations.
Well, you can add. It's not there, but there is an annotation.
And the spec under
spec.
spec.
Yeah, you can add annotations.
So I was showing that on the master branch. We have the templates that you can use for secrets plugin. And I was showing this, and I think it maybe was here. So you can have annotations, you can have labels. So you want that secret to have these labels, you want that secret to have these annotations. And then Larry had a comment similar to the comment I had the other day that these values, since this thing is going to create a secret, and this is a secret template, and it depends who you are. Like if you are like me, I know this YAML by heart, right? I know that a secret YAML can take data or data string, and then these are keys. I don't know what to call it. Yeah, these are keys. So I think Larry hit the same mental like hump that I did. Was maybe these things should be called keys. Maybe this one should be called data string. Maybe this one calls data, and maybe this one is called like key manager, ref key ID, or ref manager, because this is the one related to key manager. Go to a key manager and go and get this value. So something to think about. Then we're explaining to someone that actually knows about secret and so like, I don't want to create secrets by hand. I want to create them to a template. Then it's kind of like, wait a minute. So it's you have to pause and think for a minute.
Yeah, it's good. So string data, and key manager, whatever that value. But the other thing, the way the plugin's written, that key manager is key protect. Nothing else has been implemented, but like hyper protect could be supported. And the nice thing, hyper protect, the APIs are identical to key protect, so it's easy to swap them out. It's just the host is different.
HyperProtect, that's the one I think I was looking for the name. So HyperProtect cost more? Is it different?
It costs more. Secure? Yeah, so it's HyperProtect is hardware backed. So there's I don't know if it's on a mainframe somewhere, right? But it's running on hardware, and it's supposedly to the point where if somebody steals the chip and tries to, that you can't get into it. It's impossible. So
is that the same as HSM?
It is an HS, I mean, it is a hardware security manager, whatever. Right? It is an HSM implementation.
Okay. Yeah.
So I think I made a lightweight version, but the APIs are identical. So Key Protect, it's free up to 20 keys, and then after that, it's still pretty cheap. Yeah. Hyper Protect is $1,500 a month, I think. So for a POC or an MVP build, Key Protect is plenty sufficient, right? And you can use it as a bring your own key for encrypting the etcd database and Kubernetes and encrypting MongoDB, and you can use it to manage secrets like this.
Okay. Yeah, I also mentioned to Larry and other folks that right, this is just a pattern. So this could be if you're okay of saving the values in the etcd database, right? A lot of people use Vault because they don't want to like put those secrets in disk in etcd database. They're okay in memory, but on disk they never want to have them. So they use Vault, and then they use an init container or sidecar to go on at runtime, at boot time, to get those values out of that vault and get them in. But in this case, this also can be implemented with Vault if people are okay to save them in the etcd database because they're anyway protected by HSM and things like that. They just don't want to deal with the manual. They want to get against the automation of all this stuff.
So in that init container pattern, you still have to give the init container enough credentials to access Vault to get your keys, right?
Yeah.
So where is that stored?
I don't know, a secret.
It's just an extra step.
I'll switch to you because I think we're running out of time, so you can show the Go code. But I also have a question.
Yep.
Show me where is for this plugin, you also need the API key to get to API connect, right? So you have to create a secret in this case.
Right. So it will. Here, let me share.
So the plugin needs access credentials.
Right. So
And can I ask one question, I guess, before we switch?
Yeah.
So those keys, those CRDs that has the keys, is that a separate Git repo then where your code is? I'm guessing.
Well, so
GitHub's repo.
Wait,
Not the source code.
Where what Carlos was showing was stored, that the repository that had the secret in it, the YAML?
Yeah.
That'd be your
it can have it for dev. It can have it for one namespace, for the dev namespace, right? The source code, because our pipelines deploys to the dev, like a shot. We don't use Argo, so if we create an operator, we can put it there and then kubectl apply with the Helm chart. But the secret is a GitOps thing. Like you have 300 environments, right? You have staging, pre-prod, prod. You don't want to have that in the source code repo.
Yeah, I guess that's what I was asking is we'd want to have those secrets defined in a different repo than our source code.
Yeah, it's the folder for production for Europe. Like it will be a different repo. Like it will be a GitOps repo, one or many or branches of folders.
Okay.
And you might have the initial seed version in your source repo, and as the last step of your CI is to copy it into that other repository, and then at that point it gets customized for different deployment environments.
Yeah, you're assuming that we're using the same secret in all these environments, and I don't like secrets.
Then you manually change it for each environment, right? And there's ways to do it with different folders with customizing overlays, and doing that route, or if you're doing Helm, having different values YAML.
You have only the key ID will be different per environment.
Right.
Okay.
So you might maintain it in the source repo, but the deployment version, right, is in the Git repo, and that gets tailored for your deployment.
So would there be a timing issue if you're creating a new key? Because that key should be inserted or created. The secret should be created before the app gets deployed, right? Would that be an issue if it was?
There may be a little bit of an issue, but Kubernetes is pretty good to resolve that quickly. Like if you deploy
we can advertise the IBM composable operator.
Right.
that actually does solve that problem about the secret doesn't exist yet, but you want to deploy the deployment.yaml, so the composable wraps that into a template. I said laughing because me and Sean, we were looking at that operator yesterday trying to understand what it did. Okay. But that's the use case. Like the secret will eventually come, and Kubernetes is kind of bad at saying if you don't have if your deployment.yaml refers a secret config that doesn't exist, or a service account, you're out of here. So you have to be careful with those things.
In a failed state, it'll eventually resolve itself, but it looks ugly until then, right? It looks like you're failing.
No, I don't think so.
Doesn't it kick you back now?
It kicked you back.
Yeah.
The deployment is you're out of here.
Yeah.
Okay. So that's where Argo, though, I guess, using Argo will keep trying.
Yep, it will keep trying.
Sure. Okay.
That's why people
Yeah.
like Argo. Yep. Because they don't want to be sitting there like, doesn't work. Let me run it again. It worked. Wonder why the second time worked.
Mhm.
So this was written in Go partly as an exercise to practice Go, because but also it worked out to where the next step of an operator made sense. The only requirement for ArgoCD plugins is that there needs to be a command available in the pod. There's a bunch of different pods that Argo sets up. It's the Argo repo server. So that command just needs to be available in the pod. So the way you do it is you patch within a init container to copy your command into the. So it's just, at that point a shell script or a executable binary, whatever. So anything that can be compiled into an executable can be applied. And then the only other requirement of a plugin is that you get past the directory where your source is located, and it has to spit out valid YAML on the other end, right? It's basically a transformation engine and an enrichment thing, right? So like Carlos said, you could have a bunch of text files from some legacy application or
XML.
XML, whatever. So you can take that XML and transform it into a deployable, whatever it is, deployment secrets. That's kind of the job.
Take a liberty server.xml. It wasn't D.
There you go. There might be something there. If that's something.
Yeah.
Yeah. So anything any configuration you might have that you want to convert into a deployment. So having the YAML is probably, this example started with the YAML. Really, an operator is probably more ideal long term, but just as an exercise it works. So what there's scripts in here, and this is the plugin repo. It's under IBM Garage Cloud. So there's scripts in here, and I don't know why, but Go has this convention of they put their scripts in a directory called hack. So the install is just, it installs the dependencies, so it's just doing a patch to basically create an init container, pull down the image or the generated binary and copy it into the folder. And then so that gets the dependencies there. And then there's a patch to oh wait, that's not it. That's the uninstall. This one. There's a patch to register. So this is why with that drop down, why that value is there. Because this was registered in with the config to say, I have a plugin, and this is the command you should execute when that plugin gets applied, right? And this is the binary that got copied over during the patch.
What are you patching at that point? You're patching an Argo CR?
Argo, deployment, an Argo deployment. So.
No, this patch that you're showing here.
Right, so this patch is patching the ArgoCD. Wait, no, this is patching the CR.
CR, yeah.
Yeah. This one is patching the ArgoCD repo server.
Adding what, like a new container with your container that has the command?
Well, this adds an init container to pull down the image and copy it into a folder. It copies it into a volume, qproject install volume. And then so basically this just gets the binary into that repo server so that when you apply the patch, this thing exists. Right?
Oh, okay. So the plugin is just, it could be a shell script or something that runs inside that runtime. And since you're creating using Go is like a EF executable, like you don't depend on much, like just executable and shell. Perl will say like, I don't have Perl, like I don't know how to run this, or Python, but a shell script and a Go is like something that will run in their container.
Right. So this runs within the repo server container too.
Interesting.
And again, it takes in the directory that has that YAML in it or whatever in it, and spits out the YAML on the other side. And you can provide there's generate and init. So you can have an init thing, something that like a pre-execute step. So there's a pattern where there's an example that's out there where it uses Helm and Customize together. So you have it, renders the Helm chart into a file and then applies Customize on top of that. And so it does that through a combination of init and generate.
So they have the customized binary and the help binary client inside that container.
Well, those are already there.
Okay.
And then it's just doing a Helm init and then a Helm template and then customized build. So those whatever you can do with a set of with some shell scripts or executables, you can put in here in the plugin. So that's the first piece for how to set it up. Now, one thing, since I restructured with the operator, some of the core logic is now in the operator repo, which is one of the nice things about Go is you can reference files from external locations, right? So that's the repo. This is the operator repo. This is the generate secret is the logic that actually goes off and calls keeper check and does whatever. So in here, all it has to do is it reads the YAML files from the file system, and it calls generate secrets, and then writes those out as YAML. And then the generate secrets is just basically for each secret template. So the secret template, it comes from the operator as well. That's the CRD model.
To parse the YAML in the Git.
What's that?
To parse the YAMLs that he found in that folder.
Right. Yeah. It parses the YAML into that object. Then for each of those objects, it calls generate secret. And then so for generate secret, I'll go pull up the operator in a second. It does the logic to convert that into a core v1 secret, which is the built-in kube API model for secret. So it's just doing a translation, convert from secret template into core v1 secret, and then that's what gets printed out as YAML, and then
so plugins only work one way.
Yes.
One way straight from Git to the container, right? It doesn't make sense to have the thing now, coming back for plugins.
I think Argo, this runs inside the larger Argo controller. So Argo is doing some logic to compare the output of the last run with this output to see if there's drift, right? So it's still doing that reconciliation process on the output, but at this point,
but doesn't give you a chance to fix it.
Well, I guess it would replace it. I don't know, or patch what's there.
I see.
How it applies that, but your only job as a plugin is take what comes in and spit out what should go out, right?
Okay.
And the other nice thing, since it's an executable command, it's easy to test, right? I can run.
We lost Sean to Go. Oh my God, he discovered the benefits of Go.
I know. I was.
Yeah, I know.
Back to writing make files again and writing. We're using pointer. Pointers and everything. It's been a while since I've had to do any of that. But,
just skip over. Go to Rust. Rust is the new thing.
Yeah. Yeah. So, but Go is not too bad. It's a little clunky with some of the convention. Like all of this has to be in your Go folder. You can't put your repos, and it has to be in a file structure based off of the Git repo, right?
Yes, initial humps. Once you get over them, and everybody has the same folder, and you come into the project, it's just run hack, run the scripts in hack to generate all the Kubernetes structs, right, and interfaces, and generate all that thing so you see your code.
Yeah.
But
so now it built in the bin folder. I can just run that, and I don't have the key, the credentials, so it didn't actually go out to the connection failed, the key protect, but you can see the result, right? It rendered
the
output, because that's all it's doing, right? Is spitting out the YAML. So it's pretty easy to test, and there's not enough in here to test, but in the operator there's some test code. So you know there's a very rudimentary unit testing framework in Go, so you can write some unit tests and apply them. But
show the operator before we run out of time.
Yeah. Anyway. So this is using Operator SDK, and I'm in the middle of upgrading to the latest SDK because I want to build an OLM. Yeah. So there's Operator SDK will generate the skeleton CRD, and then it's just a matter of modeling this. You know, the data object. So you see these are those fields. This is the value, right? There's an array of values, so name, value. So to accomplish do the rename, you know, it's just a matter of updating these values here, and really can just update that value because that's how it parses JSON or YAML. There's that, and it will generate the. That's not there. It is. Oh, I haven't generated the CRD from here, but there's a command. It'll generate that for you, and then you also generate the controller. So it generates this, and really you just implement this reconcile loop.
Scaffold initial controller with one function that is reconcile. That's.
Yep. Yeah. It scaffolds all this, and then you just plug in your logic to say, hey, I want to. For each secret template, I just want to generate a secret. So it's calling that same function. And so that logic, real quick, is I just put it in service, right? It's, I haven't updated my module. So it's, it generates a secret. And so it's basically looping over the values for each one convert value. It's that metadata, the annotations, they're being updated. So then convert value is just saying if there's a key ID, then you'll get the key from key manager. If there's a value, then just process it, the string value. And if there's a base64 string, just process that. And all that gets built into a new secret model where it stores all that in the data. You know, the string data versus data, it all goes in data as a map of byte array. String and byte array map. So any questions on that? I mean, all this code is out there if you want to take a look.
So once you do once we switch to the operator, we would not need Argo plugin anymore, right? We'll be just directory. But the kicker is you saw that we went into Argo and we gave power to Argo to go ahead and be able to deploy secrets and deploy things, right? A cluster role. To the cluster role, we added the ability to add that to a CR. So now you're taking that up on you. Now you can deploy this operator, but now this operator maybe by default can watch things in its own namespace and create secrets in its own namespace. So you create the RBAC to allow you to do that. But if you want the operator to be global to watch X namespaces, maybe you don't want to watch all of them, then you have to create your RBAC enough permission to read and create secrets. Maybe the operator doesn't deal with anything else, so you scope it down to the minimum required for the operator. So, and that's where OLM, I guess, and the things packaging things into a bundle into OLM makes it easier, because if not, you'll be dealing with a lot of permutation of how do I give permission to this operator to deploy a secret over here and be able to get and list secret templates over there, or read secrets from this namespace and the secret templates from this namespace and deploy them to this other namespace, right? Sometimes you want to hide the CR in one namespace and then make it deploy the secrets in another namespace, and that's what operators does. But if you have to do that manually, you'll be dealing with a lot of permutation of RBAC rule, cluster roles, or service roles.
Yeah, and so the nice thing with if you use OLM, it's just one document, right? It's a subscription to install your operator. You just point to the catalog you want. You say the name of the operator. You say the update policy if you want it automatic or manual. I think that's it. And then you either create that in the OpenShift operators namespace, which means I want it cluster-wide, or you deploy it into a specific namespace. You also have to create an operator group if you're putting it in a specific namespace. But all that stuff that Carlos was talking about, all that gets handled for you through the bundle that you put into OLM. So I'm working with a customer right now I'm trying to move them to a custom catalog because everything Carlos just mentioned, all of the stuff that you need to install is a lot, and you need pretty high level of access to be able to do it, right? To create a CRD, you need basically cluster admin, and you need to create maybe a cluster role or whatever, right? So you can, by putting it in the catalog, then you can kind of defer some of those responsibilities to the catalog and not the individual deploying the operator.
Yeah, and OLM is something that runs on any Kubernetes cluster. It's open source, so it's not OpenShift. The O stands for OpenShift, no, for operator.
Yeah, the toolkit installs OLM, the open OLM onto Kubernetes. You do a Kubernetes install and installs Argo and Jaeger and Nexus all out of the community catalog on IKS. It'll install. We don't yet. Tecton is not available in the community catalog, so we're not doing that. But yeah, that makes it really easy too to go from. I don't know if we want to advertise that, but to go from Kubernetes to OpenShift, if they're operators out of OLM, then the only difference is it's the same subscription document. It's just the source of the of which catalog you're pulling from is different, right? And the namespaces are slightly different on Kubernetes than OpenShift, but it makes it really nice to work with those operators that way.
So maybe I missed it, but so the RBAC controls what access the operator can create, or what secrets and what namespaces the operator creates. How does the operator connect to the key protect? Is there a secret with those credentials, or? Oh
yeah, there is. So I was going
okay.
So yeah, it needs an API key. So by default, with the toolkit, we create IBM Cloud Access secret that has credentials in it. But you can also, through the setup, you can create your own secret with your own API key with whatever scope it needs, because that API key needs Reader and Reader Plus access to the key protect instance. So, so you need to put that key in the same namespace that Argo's in. But the good thing is, as opposed to, I know we're over time, so
or where the operator is, right?
Yeah, key protect access.
Or where the operator is, right? Or where the operator is. That's a good point. The nice thing with the plugin is only Argo has access in a namespace that can be highly restricted, right? Nobody has to have access to the Argo namespace. In this case, we put it in tools. It might make sense to put Argo in its own namespace, but so those credentials to get to key protect are restricted to Argo alone. Argo goes and looks them up and creates the secrets. But if you do like the init container that goes out to key protect or to Vault, it means every pod in every namespace needs access to key protect. So those credentials. Now maybe you can scope it to say this key will only give you access to. And this token will only give you access to this key. I think that's part of it, but this way it's pretty scoped in terms of who has the ability to get to key protect.
Yeah, and then sometimes you can use a mutation webhook to insert an init container. Right? You don't have access to the init container, and you don't have access from your application. So even if you want to get access, you can do that. So Larry, for the operator. So Sean's talking about the ArgoCD. For the operator is just a normal application. It's just a pod that is runs in a container that was compiled with Go. but then in the pod, you have to put the reference to a secret foobar. And in that secret foobar, you will put your IBM Protect, IBM API key that only have access to the key protect. So and that you will put into your operator, like pod definition, what are the environment variables that you want, or what is the secret that you're going to refer to, and you tell the person installing it, like, hey, create this secret with this name. When you install the operator is going to look for that secret in the pod. So you will see it in the deployment YAML on the pod spec. So that's why it's useful to go back to the basics of the foundation of, because when you get to it, the magic boils down to a pod spec, and all of them work the same way. The same thing for the cluster row and the cluster row, and I forget the other one, the namespace one.
Role, role and cluster role.
Yeah, I think it's just role. For reason I want to say it service role, because it's always associated with the service account. So you will give the service account enough. So you give enough power to the service account. Then the operator in the pod spec, you say this operator is not going to run with default. It's going to run this with this service account, and then that service account is the one that has enough power to talk to other namespaces through a cluster row, or enough power or not power to talk in the same namespace.
Okay, cool.
All right. So yeah, I think we went over the plugin aspect. So I didn't know the ArgoCD plugin worked like that. I knew you can like speak. Somebody like it's just a shell script or just a command, but I really wanted to know like what actually how do you plug it into ArgoCD like an extension? It's like a bunch of patches.
Yeah, so this is fairly basic. We can enhance this as we go, but one of the things that has come up repeatedly with customers is, well, how do I do? How do I manage secrets with Argo? So at least we have an answer.
Answer now. Yep.
To start with, and then if they have Vault or they have other, we can go from there. But
the distinction, right? And the distinction is some people want to say, and like you said, I think what most our clients and customers deal with it, they're okay like putting the secrets into etcd. They're going to do it anyway. Right. They just wanted the GitOps automation. So this is 99.9% there, or 80-20 rule. That's 80% there. And if they want that 10% of like, we're not going to store into etcd. We're going to mutate your deployment and insert an init container. You will need to, like you said, expose your key protect access.
And it uses our tools, right?
So I like the operator better, right? Because I like the scenario that I said, like you can put an operator in a different namespace and create these secret templates into a different namespace. And I think at one point I said in the secret template, which should be able to point in the spec. I don't know if we had it. In the spec, you can put the namespace you want to create the secret in.
Yep.
Yeah. So
you can. Yeah, you just.
So the customer would never be able to get the API key or key protect because that's an operator sitting in another place. You create a secret template in your namespace. The key lives in the operator, and the operator go ahead and creates a secret next to it in that other namespace, but you never expose the key protect secret or API key.
Right. And even we're putting the instance ID in the secret template. It's also supported. It can be provided in the secret that's read by the container. So if you didn't want to give people access to specify which instance they're pulling from, but that's essentially managed, right? That could be done too. So there's probably scenarios for how to lock this down further to prevent, too much access things. But the real reason to do this is to get secrets out of Git, right? So that was the first step. There may be things to harden this if you want to protect from your own employees being able to look at certain things, right? But people who have access to the cluster being able to see more than they should see, that can probably be locked down further. But the first step was, hey, we don't want to put secrets in Git. How do we work around that or provide a solution using our own infrastructure? So we need it'd be good if we had like an on-prem alternative to this as well. So we'll have to look at
What tool is using on-prem? That
I don't know.
Vault is the only one?
I'm not sure. I don't
Like
know.
Vault
I don't know if there's
on-premise?
something that could be installed in the cluster, like a secret management pod that you could.
Well, at that
you could
point,
put
I
in
would
and
just
look at.
at that point I would just use secrets. That's my ECD. Put secrets over here and transfer over there.
Yeah, maybe.
Right.
Well, if there's an
It's what-
API, the problem is it's a different audience, right? Whoever's writing the secret.
Yeah.
You could do that, right? You just have to manually go in and create the secret before you can do the deployment, or whatever. You have to know to create it. If the credentials can be put someplace, and maybe there's a UI that the team that's responsible for updating those secrets can go in and add them, and doesn't have to do Kubernetes level secrets, then maybe that's a benefit. I don't know, but
Yeah.
there's always manually creating a secret.
Yep. Yeah, it could be. I don't know if you're running OpenShift in other clouds. Maybe integrate with the AWS or Azure Vault things if they don't have this already.
Yep.
And that way is something that is we created like a multi-cloud way of like doing the secrets. Hopefully, we're not reinventing the wheel. Like fools.
So there is a listing on the ArgoCD side of how people manage secrets, but it's very much, hey, you're on your own. Here's some things, but there's a lot of work that would be required to. It's not as turnkey as this, right? So I don't think we eventually I think the product team should provide something like this, or maybe take ownership of this.
MCM maybe,
right? Yeah. Right. But until then, we fill a gap. But like I said, it's a space where there's a lot of pieces, parts, but not a very clear, concise answer.
Yeah. So I think maybe the next step is just Vault, since it's so popular, right?
Right.
You can do it here, and you can come from Vault into IBM Cloud using Key Protect, and we have a good transition. Or you want to go from IBM Key Protect to maybe AWS, and you just you're already paying for Vault anyway, HashiCorp, right? And just that's where you're doing your secrets, and your CI/CD and your YAMLs don't change. You use a secret template.
Right.
Yeah, the other one is still secret, which I'm not a fan. I'm not a fan of trusting on humans to encrypt the secret first and then check it into Git. I don't know.
Right.
It's maybe my way of thinking of my nature.
All right. Anybody else? Over. A couple people dropped.
There's not that many people left. Okay. Yeah, that was good.
Yeah. Very good.
So I have one question for you, Carlos, unrelated, and anybody else maybe.